Okay, so this is our favorite issuance here. This is our favorite thing. Let's say football. All right, so what we want to do here is we want to have a receiver, a light little receiver running really fast. Let's put a thing there. Let's say he's 150 pounds. It's pretty light. And he's moving at 5 miles an hour, I think is. And then we have right at the goal line a linebacker who's probably covering a tight end, but now sees that this guy's got the ball, is running at him at 3 miles per hour, and he's got 240 pounds on him. Right, he's a big guy. So the question here is if they meet right here at the goal line, and the linebacker, he just completely envelops the wide receiver, so he can't do anything. Does the group wide receiver plus the linebacker go into the end zone for a touchdown or out of the end zone so that we get another play? Right, so that's our question today. And we're going to do this with conservation of momentum. All right. So I've got P plus Q and Q plus P here, Q plus Q here. So basically, I guess that's the first thing we have to do. This is a complex problem just like the previous one. First, we have to go through and just calculate the bits that we know. So let's say we start with the linebacker. Let's make him capital because he's big. So he's got a momentum of 240 pounds times minus 3 miles per hour, minus because he's going backwards. So that's minus 720 pounds times miles per hour. Let's put this guy a little bit backwards since I'm writing so big. So the receiver, that's 150 pounds times 5 miles per hour. And so that's 750 pounds times miles per hour. And then their final ones, well, we know the masses, right? So we know that we have 240 pounds of mass for the linebacker. So his final momentum is 240 pounds of mass times the speed that we're going to want to find. And for the wide receiver, that is 150 pounds times the speed that we want to find. Okay, so both of these terms, this one and this one, have V's in them. And they have the same velocity because, the linebacker's tackling the wide receiver, and he's not letting the wide receiver go anywhere. They're all one big package from now on. Okay, that's what was going on. They were out of order. All right, so now we take these numbers and we just plug them back in here. So we say, all right, so P, capital P, is minus 720. So minus 720 lbm mph plus little p, which is 750 lbm times mph. Let's just say what that's equal to 30 lbm mph, which is also equal to this plus this. That's 240 pounds times V plus 150 pounds times V. And adding these two guys together is 390 pounds, lb of mass m. times the velocity. So to find the velocity, we divide both sides by 390 lbm. That'll cancel that out, and that'll give us a number. So V is equal to 30 lbm mph over 390 lbm mph. The pounds of mass cancel. There's no mph here. Okay, so pounds of mass cancel. So we have 30 over 390, which is 0.077. Yeah, the wide receiver has a little more momentum, so that's mph. So that's not a lot of miles per hour. That's not a lot of feet per second. That's like a tenth of a foot per second, but that's still positive. If it's right at the goal line, then you get a touchdown. Ignore that minus sign. So that is an application of conservation of momentum right there. It's actually a type of collision. We'll talk about this a lot more in the last unit. Okay, so thank you very much. I will see you in class. Bye now.